Hi, and welcome back to the next devlog of Toast Engine. I told you this devlog would come out quicker than devlog number 5. I've made some good progress over the last couple of weeks. But what you see right now on your screen is Toast Engine around a year ago in March 2025. And we can fade over to how we left the engine in the last devlog. Well, what you will see is that there are still things missing that were in the engine a year ago. So let's fade over to the latest version. As you can see, the most obvious thing is that the UI is back in, and I've also updated the look of the UI. I have scrapped the old 9 patch system that I used for the UI earlier, which makes the UI not as scalable as it used to be, but I think it looks a lot better and professional now, so I prefer this look than the old one. I also have new icons for the buttons, and if we press play to go into runtime, we can press Starship and we get a pop-up with some information here, and this is basically just a test to see that I can create pop-ups and fill it with information that I pull from the engine. I can close it down and get it back up again. I can drag it around. It has a connector to the Starship. In the future, when we add more and more information, I will have to start thinking about how I present the information in a way that makes sense to the user. We can add starships by a prefab system. You can see the money panel is counting down as I add them. Every starship have its individual pop-up basically. We can also get a list of all the starships. As with the other pop-up, and this can't actually be dragged. As with other pop-ups, I will fill up this with information as I go forward. This was just a test to see if I could actually pull all the starships into one pop-up. If we add a new one here and press the pop, we can talk about the new functionality that I've actually added, and that is a follow camera. So if we click this button down here, we can see that we follow the starship. The user can rotate the camera, but it can't translate it. There's no way to move here. You can just rotate. And we can cancel it, or actually you have to press the cancel button and the camera goes back to its previous position. There's also the possibility to speed up the time. You can see that if we add another starship, you can see it goes back up. One thing that I need to work on, if we follow this one here, is that you improve something in the engine, and now what looked good looks worse now. And I'm thinking about the particle system here. I need to update the particle system to improve it. It's not up to par with the rest of the engine at the moment. But yeah, that is the UI, the new UI. So let's talk a bit about the project system that I've developed a bit further. The last time we left off with the project system, we just had a pop-up where you could give your project a name and a location, and it would create a project folder and some assets folder within that project. And that was it. The project wasn't bound to anything inside of Toaster. But now what you do, you can open an old project as well now, or create a new one. You get prompted this when you start Toaster. And the project is basically bound, so you're working inside the project, not in a scene. Well, you do work in a scene, but that scene is part of a project. Previously, you would directly work in a scene, and that scene had no concept of a project or any other scene or anything. So now that we have projects, you have pointers within that project to different scenes. And in the panel here now, the project panel in the bottom left, we can see a list of the scenes in this project. We can add a new scene or import a scene from a different project if we would like. Right click here in the list to rename or delete. We can see the active scene has a sign on it. And the goal with this development cycle for project for the project system was to enable the user to move between scenes during runtime. So a good example of that, and what I ended up doing, was having a main menu scene that then moves to the game scene basically when you press play. Yeah, so we can switch over here now, go to the main menu scene by double clicking here on the scene list. Now you can see we have just a simple button that says play here, and we can press play to go to runtime, and when we press the play button it should load. Yeah, here we go, here's the Mars scene. So we've now loaded the Mars scene. It's running live when we enter it, of course, since we're playing the game now. We can press stop and we go back to the scene we had active. I can now see that the list wasn't updated accordingly. But yeah, so that's this time around with the project system. Next time I revisit the project system, I'm gonna start working on asset manager. And eventually, in the not too distant future, I'm gonna start thinking about, okay, how do I actually export a game? Because that's the end goal with the project system, to enable the user to export a game to an exe file to share, basically. There's a few steps in between that, but I'm getting there. Yeah, so awesome to see project system upgraded. So let's talk a bit about my side quest. Which I mentioned in the last video, that I will do several ways of rendering a planet, and I just added the front end in the last video. We talked a bit about for years I used an Icosphere system, and then I switched over to geometric clip mapping because I wanted to try it out. I wanted to see if I could get better results of it. But then when doing that, I felt like maybe Icosphere is better. So basically, I don't know which will end up being the best way. So I decided to implement both. Right now, Icosphere is a bit behind, basically. So this, what we're looking at now, is geometric clip mapping. And this is where we have all this fancy stuff with the terrain and so on. But now, the last week, I've actually added Icosphere rendering, and it looks a bit weird now because we're actually below the surface. But if we zoom out a bit, we can drag the planet down a bit, and as you can see, I haven't added any height to Icosphere rendering, so it looks a bit, to not say very boring at the moment. It's also very laggy. If we move back over to geometric clip mapping, we can see we have 5 million vertices rendering, and it's also easy to see how it looks here, squares in a LOD system. 5 million vertices. Go over to Icosphere, bam, we have about 1 million vertices. I think the LOD system works better here. Here we are like maybe 1 meter above the ground or something. We can optimize this a bit by activating backface culling. We're down to 236, and you can see it's a lot smoother. We can even add frustum culling, and now we're down to 145,000. And we have some settings here. We can change max subdivision, and you can see it gets more and more larger and larger triangles. Go back up 24. This is just one draw call. The whole planet right now is one draw call. We also render them as patches. So basically, one triangle is one patch, which means the patch itself can be subdivided a number of times. You can see the vertices number is changing when we do this, but you can see the kind of scale we're getting here close to the camera. It's really detailed. And we can then zoom the planet up again. Actually, if we remove frustum culling, it's easier to see the level of detail system working here. So I spent maybe one and a half week on this, maybe a bit too much time to my liking, but I always get sucked into it. the cracks are solved basically by saying, like, if we show the patches. So here we have a level of detail transition. You can see the lower triangle here has been subdivided. That means that all vertices are inside the level of detail threshold for the higher LOD, which means you can see 4 triangles within the bigger one. In the upper triangle, you can see that it's not subdivided, and it has 2 vertices inside the higher level of detail, which means that the third up here is not inside, so this doesn't get subdivided. It's the same for the triangle to the left here, but this one only has 1 vertex inside the level of detail, the higher level of detail. And if you look on the graphic to the right, you can see how this would look from a different perspective if you look at it from the side and why it becomes a crack. So basically this mid vertex gets pushed out to the sphere radius to actually have a sphere, and that basically creates a hole. I mean, it's subtle. If you go, like, if you're at high enough level of detail, the cracks will be very, very small, but you can still see the flickering when moving the planet around. So you can't see it directly, but when you move around, you will definitely see it, because you will get this kind of flickering from the background coming through. So how I decided to solve this: if you have 3 vertices inside the level of detail threshold, subdivide. If you have 1, nothing, you don't need, it's not a crack. But if you have 2, exactly 2, then you will have a cracked patch. So I flagged that, and when adding it to the buffers, I calculate the midpoint, and I will get this midpoint. And then instead of creating 1 triangle or 1 patch, I create 2 of them. And then basically I will not have a crack. The way I calculated in the shader then means that you could see this when I have the patch levels, is that this gets a higher density because it's just half the size, but it has the same amount of vertices. So I might need to do something about that in the future. The Icosphere is heavily leaning on it's more heavy on the CPU than the previous system, but I think with some optimization I can get this. Maybe this works better, who knows. We'll see which system I end up using, but it's fun to be able to just switch between the 2. So next step for the Icosphere, and I will do that when I have time and feel like I want to do something else, is that I'm gonna improve the performance on the CPU. There's some improvements there that can be done, and I'm also gonna add height, and then hopefully it will look more like real terrain. Yeah. So let's talk a bit about what I'm gonna develop, hopefully not too long, the next steps for Toast engine. And that's gonna be the shadows. You can see we have shadows here now. It's very basic shadow that I do. You can see the sun frustum here, so like if I move an object outside of that, you can see the shadow goes away. There is also some self-shadowing going on I don't know, you can see it sometimes. I'm having issues with that. Can't remember if it's when the sun is close or low on the horizon, maybe. Is it high? Yeah, you can see here it's casting self-shadows on itself. I think that's called Peter Pan in the shadow world. So yeah, I'm gonna implement cascading shadow maps. Actually, that's the last step in this version, as I call it, version 0.3. So that's what I'm gonna spend the next couple of weeks on, and after that I'll do another devlog before I start the next version. So yeah, thanks for watching this video, and I'll see you soon. Bye.